See, it is a fixed geometric entity. Because every crystal has a fixed geometry. It is a fixed geometric entity bound by plane surfaces. Meeting at sharp edges. This is with a simple language I did not borrow from the book. This is the way we see a crystal. Okay. So this is the one that you have seen, the sugar crystal. If you take a magnifying glass and take few sugar crystals, you'll find all of them they look alike. So it is a fixed geometric entity bound by plane surfaces. See, all are free. Meeting at sharp edges. This is the simplest way I can express the definition of a crystal. See here. You will find if it is spherical, this is also a geometric entity, but you will never get a crystal of this type. There are some substances which looks like this, okay, but we will not call them as crystals. Why? See here, this spherical object is also smooth, okay? It is also smooth, but what does it say? Bound by plane surfaces, meeting at sharp edges. So a sphere does not have any sharp edge. So this is not a crystal, this is a crystal. So please write these small definitions which I feel it is easy for you to remember. And I had been telling you that anywhere those, see, most of the students, they requested me to go for offline. And because of that, many students, they dropped out. But at the present situation, I had been telling you, I cannot go for offline. In fact, offline will be little risky. Now you have seen how the things are spreading. Even though Shillong, we feel it is isolated, but still people who are coming from Shillong are also being from outside to Shillong, are also being detected with it. So you do not know the places that you are visiting where any person with infection is there on. Okay. So please bear with me. If everything goes fine, I'm also very eager to teach you offline. Because in offline, we can discuss many things. All right. So now, now we go for space lattice. This is the technical term that we use. The thing which I've drawn, this is nothing but a space lattice. So space lattice is the object for the which you see by your naked eye. But this space lattice is being made by many small and tiny crystals which are not visible to us. Just like a big wall is being made by small bricks. So similarly, space lattice is also made by some smaller units, which you call them as unit cell. So that will, let me write down the definition of space lattice. The regular arrangement of the constituent particles. I told you particles can be, why you are using the particles? Because we have already seen that crystals can be made of an atom, it can be made of ions, and it can be made of molecules. So because of that, whenever you say particles, means it can be atoms, ion, or of a crystalline solid in three-dimensional space is called a space or crystal. So both are same. See, my drawing is a little poor, huh? So please don't mind. So these are the magnified view of these atoms or ions or molecules. See here. My drawing is not nice. Huh? You draw much better than me. Okay, see, this is the one. So this is a space lattice. Okay, and these, see, as the particles are regularly arranged, so their positions, this is a space lattice. And these points where these particles are being placed, okay, all these points or the places, these are called lattice points. So the regular arrangement of the constituent part, this is the regular arrangement of a crystalline solid in three dimensions. It is, you can say, this is length, this is breadth, this is height. So in three-dimensional space is called space lattice or crystal lattice. This is the one which you can view. Try to draw it nicely. Please draw much better than me. Do not copy my handwriting and drawing. Okay? In that case, you may not get mark. I'm very poor in handwriting and drawing. So I'm very, very sorry. See, as per example, I'll try to write in the board, and when the chapter will be almost over, I shall try to send them as notes. But my notes are very, very big because it, as I have written little big, why? This is for your entrance. Your book is too small and too concise. So if you read too small and too concise, it's difficult for you to understand. Each point in the space lattice represents the position of a constituent particle. Also known as lattice. Each point in the space lattice has same environment. I'll explain to you. See, if I go deep, it is outside. What is the meaning of environment? See here, if you look at this, see, if you look from this front portion, you'll find this middle one is being surrounded by how many? Surrounded by, see, so many particles. If I magnify this, again you'll find they're also being surrounded by so many number of particles, same number. See here, if I go for it, it is surrounded by same number. So each point in the space lattice or lattice points has the same environment. As that of any other point. In the okay. Now suppose first you finish writing, then I'll tell you. Finish it. Okay. See here. So this is a wall of your compound. Say it is 12 feet long, 1 feet wide, 6 feet tall. If you want to make wall like this, generally we make the wall with the help of what? With the help of bricks. We cannot get such a big brick. Even if they bring it, make it also, we will not be able to bring it from there because it will break. So how do you make it? See here. This one assume that each brick is 4 inch. Huh? Say it is okay. Let me make it very simple. That you have taken a brick. Brick is of this size. Okay. Say it is 6 inch. This is 12 inch or 1 feet. Okay. And height is, say it is 4. All right. So what you will do? We'll lay the brick in this. Okay. Now, the bricks are like this. This is the brick. Okay. This you cannot see because it is hidden from this. So see here. This is the, when this brick we lay lengthwise, we lay breadthwise. This is the breadth, na? So it is what? It is 6 inch, na? So this is like this. See now. Here we have 2 bricks are like this. Huh? It is like this. Hmm? See here. So when these bricks we propagate in lengthwise, breadthwise, and heightwise, then ultimately the complete wall is being made. Okay. Now in this case, if this is the single brick, this is single brick. When you go on laying one from left hand side to right hand side, front to back, then top, from bottom to top, ultimately you get this. So is it not this brick is being repeated? Say this is the brick. You repeat n times in one direction, n1 times in other direction, and n2 times in n double prime in other direction. Ultimately you get the one. So this is the unit. This is the unit which is being repeated lengthwise, breadthwise, and heightwise. Similarly, the crystal which we have seen, this crystal initially is being made by a smaller unit like bricks. Then this crystal is being repeated. This crystal is being repeated. Okay, this crystal is being repeated lengthwise, then breadthwise. Okay, see, this is the breadth. Okay, you have repeated, so ultimately you have got this brick crystals. And this smaller unit, which when repeated in all directions gives us a complete space lattice or crystal, we call it units. So this is a unit. And in this case, it is a single. So now let us write down what is an unit cell. These unit cells are not visible to us in a naked eye. Unit cell you can see, not even with the help of microscope also it is very difficult to visualize. Okay, if you go for an electron microscope, that is something else, otherwise you will not be able to visualize. So how do you feel this presence? We do feel this presence by the help of X-ray. Unit cell. the smallest portion of the complete space lattice, which when repeated again and again in different directions, means what? Length, breadth, and height. Produce the complete space lattice is called the unit cell. I am trying to give you the simplest possible definition. Okay, it may be from your book or it may not. Definition I can quote from anywhere. Only thing is that this language should be simple. Moment you finish writing, please tell me.
Finished, sir.
Okay. So now, how can you describe a unit cell? How can you? How can you classify them? Because every crystal has a definite shape. So if my brick is small, in that case, if I arrange them, it will have a different shape than if the brick is big. Or it will be different from that where the brick is very thin. If you go to the old historical monuments, you'll find different types of bricks are being made to give different shape of the building. So parameters of a unit cell. This is a unit cell. Okay. See here, this These are the edges of the piston, and these are the angles. So this we call it A, this we call it B, and this we call it C. This is we call it. Please mind it. In geometry in the school that you have learned, you can put ABC anywhere, but here you cannot put it like this. It is fixed. This is being internationally accepted. You cannot change it. Just like the IUPAC name, you cannot change it. It follows the IUPAC rule. So this also you cannot change it. These are also being fixed by IUPAC. See here, here we have written ABC clockwise. A, B, C. These are the edge length. Now about the angle. Okay. So angles are also fixed. Okay. Now you put it here alpha. Okay. This is beta. And this is gamma. How to remember this one? So I'll show you a technique like this. This is A, this is B, and this is C. See here, if you look at this straight line, this, if I extend in this side, opposite side, I'll get alpha. This is B. If I extend it this side, this will be opposite of this side. So it will be what? B. This is C is in this direction. Okay. So in this case, opposite is what? Will be this direction. So it is. Could you understand? See here. This is also written clockwise. But here we have started A from our right hand side. And here we have taken alpha from our left hand side. So I think this is the simplest way to remember. This you cannot change it. These are fixed. So these are the angle. These are the planes. See, is it not a plane? Huh? So this is the places is just like that. The planes are meeting, like this. These planes are meeting like this. Huh? This one is that we have drawn. Huh? Is the alpha. So it is alpha. This is beta, and this is gamma. Now, depending upon the length of alpha, beta, gamma, and the angle of alpha, beta, gamma, you will find there are different types of crystals are there. Different types of crystals are there. So these are the parameters by which we can find. So let me write down. Okay. Use different parameters. So let me remove this. We'll write now here. A unit cell is characterized by the following parameters. Okay. 1. Relative length of A, B, and C. Of the edges along the axis. Or axial distances. Second, axial angles, alpha, beta, and gamma. Between the pairs of edges. Okay. So what are the edges? B, C. Then C, A. Then, sorry, N, A, B. See how to remember. These are, we call it axial circular order. So, see, circular order. A, see, it is A, B, C. So, see here. How do you write B, C? After B, C, what comes? A. After comes A, what? B. Sorry. So BC, sorry, BC, then it will be CA, cyclic order. So BC, then CA, then A. So between BC, what you have? This alpha. Then what you have? Beta. What you have? Gamma. See, very interesting. In Greek language, alpha is A. What is missing here? B and C, what is missing? A. So is alpha. C and A, what is missing? B. So it is beta. And A and B, what is missing? The gamma. See. You always find your own way to remember it. I have not by hearted chemistry. Okay. Many of my teachers also told me that if you want to get good marks, you by heart. I did not tell anything to them. My logic was, if science is a subject of logic, then why should I by heart? So I tried my way to remember it. Okay, I was not a good student like you people. But somehow I find this is the way I remembered. These are the cyclic order. Okay. Now suppose we want to make crystals. Say in your school they have told you, make some crystals. Okay? Model. You have to make the model. Many times in CBSE schools they are being told to make model. So you want to make a model, we know crystal, all crystals are three-dimensional. So whether you want to make a three-dimensional crystal or suppose you want to make your own house. So what will do? For a three-dimensional object, first thing that you have to do is one dimension. Then what you have to do? You have to go for two dimension. It becomes a plane. So when you are going to make a house or your father is making a house, you will see the people who are working there, they first make a foundation. Foundation is always two dimension. Okay? Then after that, they will start erecting the pillar. So it may happen the height of the pillar may be same as their length and breadth. So when you make it like this, you know you are going to get a cube. You are going to get a cube. Now, if you want to make little different, see here, in cube is what? We know that what is this? So if we extend it, if we extend this one, is it not A? So okay, I'll write it here. This is A, this is B, this is C. Now you know between B and C what will have? Alpha. Between C and A, what is missing? B will put beta. Between A and B, what is missing? C, I told you in Latin or Greek, it is called gamma. Now, just by having different variation, say it is A equal to B, B equal to C, and alpha equal to beta, beta equal to gamma, and all of them are 90 degrees, you can get a fixed geometric shape, which we, right from our childhood, you know, we call it cube. All right? But in your book, something is missing. It's very fundamental, but very simple. See, shape of the crystal also depends upon their floor. In your house, you can have a room which is square in size, which you can have a room where you find it is rectangular in size. So initial shape of the crystal also depends upon the their base. So before I go for three-dimensional crystal structure, let me write here two-dimensional crystal. Okay. If you find I am wrong, immediately correct. See, we have millions and millions of crystal here. But it's very interesting, you know, there are only 5 two-dimensional crystal layers. So there are all together 5 types of two-dimensional crystal. This one I'm writing only for the end. Okay, what are those? Again, if my drawings are not nice, you will tell me. What do you call it? Square. What do you call it? Rectangle. Okay. What do you call this one? This square, this rectangle, what do you call this one? Hello? Can you hear me?
Parallelogram.
Yes, we call it parallelogram. What do you call this one? What do you call it?
Rhombus.
Oh, I thought you call it Burpee. See, we should always start from the base. Millions and millions of crystals are there, but it's unique. They are made of by any one of these 5 crystal patterns. And this is known as two-dimensional crystal lattice. Hello? Hello? Oh, yes. Yes. Oh, hello? My house is near NIT Meghalaya. Yeah, the road which goes down little, you come little down. I'm coming. Please excuse me. Huh? So you come little down on the right hand side. Little down. After you come little down. Sorry, huh? Now see here. With these five types of the two-dimensional crystal lattices, we can have 7 types of crystal systems. Three-dimensional crystal lattice or system. Hmm. Hmm. Okay. So these are, we call it cubic. In cubic, please see from the book. Huh? I'm not writing all this thing. Cubic. In cubic, what we know? A equal to B equal to C, and alpha equal to beta equal to gamma equal to 90. Okay. Then we can have tetragonal. Then we can have ortho rhombic. Then 4 rhombohedral or trigonal. I'll do little change. Yeah? I'm little careful about your entrance exam. Because of that, I have written many things extra. This is called cubic or isometric. Means all same. All I told you, system. So these are all. Triclinic systems, and 7 is hexagonal systems. This angle and everything you see from the book. Now, in this case, let me write first this one. Again, this is for entrance. A equal to B equal to C. Alpha equal to beta equal to gamma equal to 90 degree. And this one, alpha not equal to beta, not equal to gamma. Sorry. A is not equal to B, not equal to C. And alpha is not equal to beta, not equal to gamma, not equal to 90. This is right. After that, we will write. Okay, done?
Yes, sir.
So this is for your entrance. So this is the way we can classify the crystal. So here the crystals are being classified on the basis of their shape. Now again we go for the classification of crystals depending on the number of the particles the crystal has. Okay? So now see now. I told you these are the constituent particles. If we join, then okay. So this is a unit cell. This is a unit cell. So how many constituent particles we require to make a unit cell? Minimum we require 4 from the bottom and 4 from the top. Here length may be anything, angle may be anything. See here, with the same type of thing, if the distances are more, okay, what will happen now? So this is also a unit cell. This is also a unit cell. This is also a unit cell. If I tilt it, then also it will be same. So what is the minimum number of particles to make a crystal? Except hexagonal. If you don't understand, you will tell me, huh? Because you are taking help because you have some doubt. Okay? See now. See. This is for this. So for a hexagonal, you require 6 from the bottom and 6 from the top. So other than this, all this geometric, whatever the shape, whatever their a value of a, b, c, whether they're same or different, it may happen that a plus a is equal to b is equal to c. It may happen that a equal to b but not equal to c. You may find alpha equal to beta equal to gamma equal to 90 degree. It may not be 90 degree, but in all these cases, how many particles we require? Here you require. So this is the minimum requirement for making crystals. All right. So if you go on the basis of this, so we can classify crystal into 2 categories. We call it simple or primitive unit cells. This is the simplest possible. See, you want to make a table. See here, you want to make a table. So table require what? This is a table. It must have 4 legs. Is it not? 4 legs are essential to make a table. You can use any type of wood that you have. If you want to make it very cheap, then you can go for a buy a cheaper quality of wood. If you want to make it costly, you go for costly wood. If you want the table should be tall, then put the legs longer. If you want to make it short, you can make it smaller. But you require, see here, so you can compare this with our crystal. So this is the frame. So 4 from bottom and 4 from the top. All right. So this one you call it simple and primitive unit cell. Now, why do you call it primitive? Primitive word which has come from our historical evolution. That in primitive stage, people had the minimum thing for survival. They required a small piece of cloth to cover themselves. In the initial civilization, you did not have the denim jeans. Trousers were not there. Jackets were not there. So whatever minimum clothing they require, they used it. Whatever minimum thing, the substance they require to eat, they used it. So we call it to be simple and primitive. These are the examples of simple and primitive units. Just like that, if you want to make a house, you require 4 pillars. Without 4 pillars, you cannot make a house. On the top of the pillar, you have the roof, and at the bottom, you have floor. After you make a house, then you can put different types of furniture inside the house. It may have minimum furniture, it may not have furniture. So depending on that, your house will look like. But this is the infrastructure of a house, require 4 pillars, followed by walls. So these are the walls. So we call it simple and primitive. After the formation of crystal, you may find one particle is inside the crystal, just in the center of the crystal. Some cases you may find that in every face, okay, see top, bottom, right hand side, left hand side, front, back. This type of particles also may be there. In some cases, you will find okay, some cases you may find one particle is on the top and one. So now these are not simple crystals. Okay, so we call them as complex or non-primitive unit. So what is the simple and primitive unit cells? Simple or primitive unit. The unit cell in which the constituent particles are present. Only at, see, are they not the corner? Only at its corners is called simple or primitive unit cell. So all the 7 crystal systems that I have told you, qubit, then tetragonal, orthorhombic, rhombohedral, monoclinic, triclinic, and hexagonal. All 7 crystal system shows simple and primitive unit cell. Why? First, the structure is being formed. So all of them are initially simple or primitive. Out of them, some of the structures can incorporate a particle within it. We call them as body centered. Some of them can have it on their surfaces or phases. We call them as face centered. And some of them can have only at the alternate position. See here. So we call them as end centered. So these are called complex or non-primitive units. So please write. And after that, please draw a simple and primitive unit cell after that. I told you this is the first time that you have come across such geometric figure in solid. If you don't understand, ask me repeatedly. Please take the advantage of online coaching. Okay? This pandemic is going to last. You have to be habituated with online coaching, and anything which you do not understand, ask me. And whatever thing I taught you, immediately read. If you have any doubt, next ask. So Pradeep, draw this. Okay. So now we'll write. In your book, they will mention non-primitive unit cells, but it is also called complex. So now we'll go for complex or non-primitive units. In these unit cells, constituent particles are located not only at their corners but also at some position like body centered or face. They can be classified as body centered unit cells, face centered unit cells, and end centered unit cells. In this unit cell, the constituent particles are present at the corners as well as in the center of the unit cells. Okay. This is this, and in the middle is the this. Okay, so you write here body centered unit cell. Please excuse me for my bad drawing. You will do much better than cells. Okay, so what you will draw? See here, this top, bottom, right, left, front, back. So here you will write centered unit cells. Okay, done it. Now we'll go for n centered. Okay. N center. See here, everything is same. Now it says in the alternate phase. Yeah. What is the meaning of alternate? Tell me. Alternate is not next. Next to next. See here. Is this? See here. In this one, this, and the back side is not the. It is the next one. So next to next is what? From here, next to next is this. From here, next is this, next is this. So it will be here. So what should I write now? In this unit says constituent particles are present. Please do the correction. At the corners of the unit cell as well as at the center of the alternate phases. So this is the one. This is called end center. End center. The beauty of this one. See, when we see human being, if you talk with him, mix with him, then after that you classify this human being into two categories. You say this fellow is very simple, and second one you say is very complicated. Okay, so let us try to classify the. Ultimately, let us go see how many types of crystal lattices are there. Okay. So you don't write, just okay. Two-dimensional, how many? 5. 3 three-dimensional crystal system. Okay, it is 7. Now see, in this 7, all of them initially form the crystal, and we call it simple and primitive crystals. And out of them, some of them can have some more particles within them, either in the body or in the face. Okay, so let me write now. So I'll write now here cubic. Okay, cubic system. Okay, so cubic system has, I told you all of them will have simple. Okay, I'll write down all of them first. এত ভালো মানুষ। You see, it is given in your book, but please see. See, all of them have simple, because this is the way they form. Then after that, some of them incorporate the particles within them. Okay. So you can have now body centered and face centered. Total how many? Sorry. So total 3. Then it is total 2. Okay. Then body centered, face centered, and centered. Total how many? 4. Okay. Then rhombohedral, only 1. This is 1. This is 1. All right. Now let us see how many crystals are there. See here. 3 plus 2 plus 4 and 1, 2, 3, 4. Did I make any mistake? Simple body. Oh, monoclinic and center. Monoclinic and so it is. So it is 3 plus 2 plus 4 plus 1 plus 2 plus 1 plus 1 plus. So how much it comes? 3 plus 2 is 5, 5 plus 4 is 9, 9 plus 1, 10, total 4. Okay? So these are commonly called brevis lattices. See, brevis, he is a French mathematician. He have never played with the crystal like a person from physics and chemistry. He theoretically predicted the different possibility of formation of crystals. And exactly it has matched. Just to honor his contribution in the crystal study, these 14 types of crystals are called brevis lattices. Are called brevis lattices. All right. So this I may come from for your 1 mark question in CBSE. This is not in your book. This is not going to come. This I have given for entrance. How many crystal systems are there? 7. How many brevis lattices are there? 14. Because brevis lattices incorporates both simple and primitive unit cells. Both simple and the complex unit cells. Complex unit cells are of 3 types. We call it body-centered, then we call it face-centered, and we call it end-centered unit cells. Okay, write down. Okay, finish, written.
Finish, sir.
Okay. Then for today is bye. From next week we'll go to more serious part of it. So whatever things I have taught you, please go through it. If you have any question, you ask me on Tuesday. Okay. And please, all of you, mark your presence. You go. বুঝিনা তুমি না আমার কথা আজকে নাকি আমি তো দিন কইলাম না ভৌমিকদার ফোন আমি তো না না ভৌমিকদার ব্যাপারে আপনি মানে দুদিন আগে ভৌমিকদার সঙ্গে বলি কেন কইছি জানো ভৌমিকদারে আমি অন্য অবস্থায় মেসেজ পাঠাই আমি দুই ভৌমিকদারে মেসেজ পাঠাইছি আমার কাছে সবারই ফোন নাম্বার খালি নববর্ষ দেন না ভৌমিকদা আমার মধ্যে মধ্যে এমনিই মেসেজ হ্যাঁ কোনটা ভৌমিকদা তারা ফার্মেসি মেসি আছে দীপক মজুমদার আমি আর মেসেজ পাঠাই না তার প্রমোশনের পরে পাঠাইলাম তারপর আরেকবার পাঠাইলাম কোনো জবাব দিছে হ্যাঁ আমি লিখে পাঠাইছি আমার দরকার নেই